All right, chapter 17 homework problem. I'm going to go with question number 2. Question number 2 here is a little bit complicated, and that's because there's lots of information that's provided to you, and it seems almost like you have all the information that you need, but you also see it also kind of seems like you have the answer provided to you. This question reads, this question reads, you are asked to make a buffer with a pH of 4. You have benzoic acid, and you have sodium benzoate. Now, you have to make 100 milliliters of this buffer that has a pH of 4. Benzoic acid has a pKa of 4.20, and all these things that are adding up, you've got pH, you've got pKa, and then you have an acid and its conjugate base. Now, one thing that's important for you to know is whenever you look at something like benzoic acid, and anytime, you have a little bit of a clue there. Whenever you see something acid, think that is our HA, and then benzoate is our A-. So all these things put together, you have what you need for the Henderson-Hasselbalch equation, which is pH equals pKa plus log of the concentration of A over HA. Now here's where it gets a little bit complicated. You're provided with concentrations. One concentration that you're provided with is benzoic acid, which has a concentration of 0.1 molar. Benzoic acid, which is 0.1 molar, and benzoate, which has a concentration of 0.18 molar. Now the tricky thing is, what are the volumes? That's really the question that we're after. The question is, what volume do we need? So what you can do with this is you can plug some values in. For instance, pH is 4. pK is 4.2, and that is plus log of concentration A- over HA. Now the thing is, you have those two concentrations, but these are of the solutions. So what you're basically asked is it 45 milliliters of the benzoate and then 55 milliliters of the benzoic acid? That's essentially the question that you're being asked. Now, in order to answer that, what you need to do is rearrange this equation so that you have minus 4.2 minus 4.2. That gives us negative 0.2 equals log of the concentration of A over the concentration of HA. Now, what we can do is raise both these 10 to that power, so 10 to the log of A over HA, and 10 to the negative second. Well, 10 to the negative 0.2 is 0.63. And then this whole function right here basically is eliminated. So we're left with A over HA. Now, this is where you have to make kind of I don't know if I would say it's a leap necessarily, but you have to, again, understand this part of the question. We have these concentrations, but those are not the concentrations in the actual solution. Those are the concentrations of the solutions that are combined. So those are kind of your starter solutions. This is going to give us, what we're about to solve for, is it's going to give us the volumes of each of the two solutions and how they're mixed together. So what we're going to do is say 0.63 is equal to x over 0, or x times 0.18. That is divided by 100 minus x times 0.1. Now what we're going to do with this is we're going to be solving for x, and x is going to be one of the volumes. Specifically, it's going to be the volume of our benzoate. So what you get with this is on the bottom of this equation, so we get 0.63 equals 0.18x over 10 minus 0.1x, and then we multiply each side by that. 10 minus 0.1x, 10 times all of this over here, and 10 times 0.63 is 6.3 minus 0.063x equals 0.18x, so plus 0.063x is going to be 6.3 equals 0.243x divided by 0.243, and you get x equals 25.9 or 26 milliliters. So this gives us our volume of benzoate, and by that being 26 milliliters, then we can compare our volume of benzoic acid, which is 74 milliliters, because these two volumes, what do they have to add up to? They have to add up to 100 milliliters. All right, I hope that was helpful.